A warm welcome back to the Forensic Detailing channel. Let's get the zoom right. Do not forget to hit that subscribe button. So today we're coming back and we're revisiting this particular product here. Whoa. This is a product by a new brand called Laboratories Fusion1 solid state ceramic. I got pretty excited about this product because it's essentially a paste wax that isn't really a paste wax and has a very interesting chemical composition, if you like. If you didn't see the main video, this is a true ceramic wax. So it contains silane material that you'll find in ceramic coatings rather than just SiO2 polymers or fumed silica or whatever, you know, stuff you could put in there to call it a ceramic wax, but it's not really the same stuff as a ceramic coating. So this has some material that's used in ceramic coating, but the backbone of the material, because obviously it looks like a wax, as opposed to a ceramic coating, which is a liquid. So the backbone of it is a mixture of polyethylene, so like a polymer plastic, and silica gel that are dissolved down, mixed in with the silane material, and then in there are solvents, different forms of solvent, and some carrier oils, which are, I believe, are silicon oils, okay? So that's our composition, which is highly unusual, you know, for wax making, and that's why I was interested in it. And this product, as we mentioned, is only £30 for around 200 grams or 200 mil of wax. So it's also a lot more affordable than other true ceramic waxes, of which there are only a handful of other ones: Angel Wax Enigma, Fireball Fusion, which is, we didn't mention that, but it's got the same name. They could have called it perhaps something other than Fusion, because there's already a ceramic wax called Fusion. Kamikaze Infinity Wax is a true ceramic one, so that's 3. And possibly Infinity Wax, the brand, have a Synergy Wax, which might be ceramic as well, and I might take a look at that, as I said. So there's the history of this. Now, this particular product, we learned that its application is a little bit more involved than a sort of show wax where you just kind of spread and buff. This needs a good secondary buff after that sort of 5 or 10 minute cure, just to make sure you don't have any sort of smeariness or films that you haven't fully removed. So secondary buff with a good clean cloth to get you that really good finish. We mentioned it doesn't darken off quite as much as sort of traditional Nuba-based waxes, but it is extremely hydrophobic on application, which is really cool. We like that. And the product claims 12.5 months durability. Now, out there on that test panel, all these products have been sat outside for about 2 weeks. And I said I would try and wash it every single day. Well, some days I haven't been here. I've done 13 wash passes and I'm about to do 14, which puts an accelerated level of deg on this panel beyond what you will see in real life. But what I want to do is I've just kept this little bucket with this has got Geon Bathe in it, about 1 to 500. So what I'm going to just do is go out and just wash the panel off. Before I do, it's really important. You can see, if you look at that panel, the tape lines where there was tape, there's different water behaviour. So you can kind of see that all of these products are still on that panel. I believe the material is still there, which is important because unfortunately, what I am seeing with this Fusion wax is that the hydrophobic performance does tail off. So it's pouring with rain. So I'm going to just sweep across this like this. So I'm rubbing roughly the same amount, just like I'm washing this panel off, okay? So just washing that panel off consistently. So that's a bit like washing a car, okay? So let's put that back in there. Let's get our hose and rinse this detergent off, which is free rinsing and shouldn't give me any cationic film. And you can see there our Fuso formula is quite repellent. Slow, a little bit of slowness on the side. Now this is our Fusion1. Now there is still repellency going on. It's pulling it, but a lot of it's gone. This is our Built Hamber double speed wax. Blow that over that way. You can see it's a bit more rapid, but its repellency has been degraded. It's not all like freshly beady, but it's clearing the water, and you can clearly see it's still going, obviously. And this is our Auto Glim ultra high definition wax. Which again is really degraded, but it's still on there, and it's still slowly forcing that water off. So all three products are still there, but essentially you can kind of see it's hard for me to flood most of them. It's impossible to flood the Fuso because it's still quite zingy, but I can flood this quite easily. Even I can't flood the Built Hamber at all, and the Auto Glim. So what we're seeing here, if I just tilt that, so we just shoot some of that water off. It's all quite slow. It's all quite slow. It's not as slow as where there's no product. The water's clinging to the bare panel, but it's very slow now. Now, while I'm talking, I'll overlay you the shot of what happened when I took this product and did the first wash pass over it. And basically what happened was, so it had 7 days before the detergent hit it, but when I hit it and washed it for the first time, the hydrophobic performance of the Fusion dropped noticeably from that zingy, repellent, beady thing to sort of like, you know, sheeting. So there was a big drop off the first time that the detergents hit the panel and it was washed. So what I'm seeing with the Fusion1 is it doesn't maintain its hydrophobic performance as well as those three other products, and hopefully that simple demo will show you that. Okay, it doesn't maintain its hydrophobic performance. Why are you wording it that way? Because you can clearly see even now the bare panels where there's no product. That's just polished and panel wiped, and I taped over that before I put the product on. So you can see what a bare panel is, and you can see that that product is still there. So the material is still there, but the hydrophobics are heavily diminished to the point where you could hardly see it, and you'd think it's almost close to kind of like how it looks when there's no product there. Why is the question? Well, let me just answer that, and there's lots of avenues to explore with this. So the first avenue, if you put a ceramic coating down on a test panel in the same way on a strip, okay, and you plonk a high spot of ceramic coating, so you've got a mountain of it that cures off, and you've got this mound that you can see, a high spot. The same thing will happen to a ceramic coating, but it might take 5 to 6 months for that to happen, where the water behaviour is gone and it looks like the panel's flat and your coating has failed. But you dry the panel off and look at it and get some light on it, you can still see the big chunking high spot of material of ceramic coating that's still there, but it's not hydrophobic and it's not beading water. Why does that happen? Well, I think it happens because the surface is being weathered on, and it's getting wet, and it's getting mineral deposits, and it's getting surfactant films, and it's getting dirt embedding into it. And I think it just blocks the hydrophobic qualities of that coating. But there's another thing that goes on as well, and that's what I think is affecting the the Liquid Laboratory Fusion1 hydrophobics, is that when you the carrier of this particular product is silicon oils, I believe, from the SDS. And silicon is very repellent and beady and all that sort of stuff. But it's it's probably a liquid by default, that carrier, and it washes out of the film, I think. It's the same when you have an oily paste wax. If you put an oily paste wax down on this car and spray it with water, they can bead and be really repellent and you're really satisfied. But you could wash the car and then most of that beading goes and you get this flat sheeting action. And a lot of time it's because you're washing the oil component of the material. You know, you're washing that out of the material and you're leaving the core stuff that's solidified and is kind of stuck on the panel. Now, I think, and this is the interesting stuff, is that the backbone of this particular product, and forgive me if the camera's a bit wet and horrible, I think the backbone of this, the polymer, polyethylene and the silica gel, if you took those materials and you melted them down and you filled them up with enough solvents that they were sort of in this pasty, semi-dissolved form with no carrier oil, and you put that as a wax on a surface, you let the stuff vape off, you buff it, it will be dry and it won't be a great usable wax. But I also think it wouldn't be that repellent. Because it doesn't have a sort of carrier oil which has got the repellency. So I think the backbone choices of material that are used here, the polymer and the silica gel, are not as repellent, and there's probably not enough coating in there, and silane itself isn't massively hydrophobic. So I think a lot of the hydrophobicity is coming from the carrier and it's getting washed away. That's what I think. Now, why do you think that? And could you be wrong? Yes, I could, but that's what I think is from my wax making days. I think you're washing away the oils on this. So why do these products maintain hydrophobicity better? Fuso, I believe, it's backboned differently. So it's not backboned with all carnauba wax, like just carnauba where it's all grainy. I think it's backboned with a different wax that's hydrophobic, possibly paraffin wax. So again, going back to my example, if I dissolve paraffin down and mix it with loads of solvent, we did this test. This was back in the early days of the wax making. If anyone remembers that, you've been around. We did it with carnauba, we did it with montan, we did it with beeswax, we did it with paraffin wax, we did it with a whole load of stuff. Because that gets you to learn about the product. And what I learned there, the material, sorry, is that the paraffin backboned material is, when you've just got a film of that repellency lasts. So you could take a pure paraffin that's dissolved and paraffin wax and put it on a surface and that repellency stays. You could take a carnauba wax with oils in it, put it on a surface and they look similar, but then that one degrades more. So it's all to do with the composition, I think. So the bottom line is, this may well last 12.5 months on a panel, like at some level that you might be able to observe. But the layman's way that we all observe durability is through how hydrophobic performance is maintained, rightly or wrongly. And it's not an exact science going just by hydrophobicity, but it's typically all we have. What other ways can you do it? Well, you can really degrade a panel visually, so it's terrible. Really, like you could wet sand it or dry sand it to P5000 or P3000 and have a terrible finish, shine that finish up with a product like a wax, measure gloss performance and measure gloss degradation back to whatever the base readings were and use that to infer durability. It's not that accurate, but it gives you another means. What other ways can you test it? I'm not too sure really. Visually, like we're doing there, you can still see that the material's on the panel. But beyond that, I'm not too sure. So we have to keep it simple because if you say that, well, that product could still be there for 12.5 months, you have to apply that to every product you ever reviewed historically. And we've never sort of stated that. In the past, if a product's not beading after 3 months, we kind of say, well, that's gone now, you know. So it's like a get out of jail card that I could apply to any single product, and I could say it doesn't matter if it's not beading, it's still there. So I think quite simply, the way to state it is the fairest way to say that the hydrophobic performance of this product unfortunately diminishes quite quickly. And if you like to maintain that beading, then this product on its own is going to degrade. That beading is going to degrade. You could counter that again by saying, well, pick a suitable topper detail spray with lots of hydrophobicity and just wash your car with that and it will keep the beads going. Yeah, you can say that, and that's absolutely true. And it's true of ceramic coatings, it's true of everything. Maintaining it and putting a little bit of zing back in it is part of the name of the game. But it's nice when it isn't. The reason, like if we take a product like the original Fuso coat, the reason that is so popular within the detailing scene, you know, it's a bit of a Marmite product. Some people say it's horrible and they don't like it, but it's very popular and everyone's tried it, and it's, you know, it's a viral type product that's done really well, is because it maintains that observable hydrophobic performance. You can see it for your own eyes. In 10 years of product testing, you know, thousands of products, maybe not thousands of LSP products, but hundreds of LSP products, I don't think I found a product which can outperform durability-wise that Fuso coat. It's a known quantity, isn't it? It's just a monster. And the fact that it's probably decades old as a technology is impressive. And here's a simple thing, is that I was really excited about Fusion because it's a modern product with modern materials with a very similar durability claim. And the absolute icing on the cake for me would have been to do this test and say to you, look, it's outbeating the Fuso, it's outbeating the double speed, it's outbeating the Autoglim, it's outlasting them visually to the layman's, but I can't see it. So there we go, we have our answer. So is this Fusion, is it no good? Is it a turkey? Absolutely not. No, it's clever. It's also the company's first kind of product, if you like. It's their first attempt, and it's so advanced chemically, and it's such an interesting product chemically. And the fact there's all these material choices are being used which are not normal, I think it's well within the capability, you know, to make something which maintains its hydrophobic performance better. The only problem is it's going to require, I think, different materials to backbone with. And then it gets complicated because you start running out of options. What are the benefits of backboning it with polyethylene and silica gel? And the answer might be those materials actually last longer than a traditional organic wax. But if they don't display their hydrophobic properties because they're not hydrophobic backbone materials, to the layman's, it's going to look like this product doesn't last as long. So it's the emperor's new clothes scenario. And that's why maintenance of hydrophobic performance is such a problem, especially with this type of product. Less so, funny enough, less so with water-based products where the material, where they don't have like, well, they can have silicons in them, they can have water miscible kind of silicons, but a lot of time a water-based spray sealant will use specific siloxane products, cationic siloxane products, which, you know, are drawn, they're amino-functional, it sounds clever, they're drawn to the clear coat, and they bond on like magnets, and your film of cationic material bonds, and those cationic materials, well, funny enough, they can benefit from other things being mixed in with them, you know, to make them more hydrophobic. And there's probably similar problems going on. Anyway, digressing. You get the idea with this. Fusion1 is a very interesting product, and for 30 quid, you should check it out still. Let me know your thoughts on durability, because it's so new, we don't have that data yet, but I'm expecting people to probably observe the same thing. If their cars are kept outside, they may see a degradation of the hydrophobic performance after they start washing the car and through subsequent washes. That's at least what I'm seeing, and you've seen the results there. So, like I say, still a very cool product, very cool, and I'm really interested to see what happens next, and you know what else they can come up with. I think they've got coatings coming out, and they'll be playing around with stuff and playing around with materials, and that's what it's all about for me. So yes, really interesting. Got my juices going. Am I really disappointed? Well, like I say, it'd have been the icing on the cake if it just kept going, kept beading us. You know, it's like, look at this. I can smack it with anything. It just lasts on the panel. It's a bit disappointing it doesn't do that, but it's not the end of the world for me. And the chemistry excites me. So there we go, guys. Thank you for watching. Stay tuned to the channel. I've got some more stuff to shoot now.